This meeting is being recorded.
In this next video, we're going to talk about the topic of the auto-ionization of water. And we have a couple definitions to start with here. So this term, amphoteric, means that water can act as an acid or base. So act as an acid or base. The second term here, this auto-ionization, means that when we have water, pure water specifically, a few molecules act as bases and a few act as acids. So we actually get something that we could write like this, where we have liquid water. Some of those molecules, again, will be acid, some will be base. We get this equilibrium that's established through this auto-ionization process. So we just automatically, if you will, get ions to form when we have liquid water. So we can think in terms of this equilibrium here that's established, and therefore we would write the equilibrium constant, Kw here, as the products, right? So the concentration of hydronium times the concentration of hydroxide, and this has a known value, which is actually given right below here. This is equal to 1 times 10 to the negative 14th. So again, the product of these two concentrations of ions, hydroxide and hydronium, will give you that 1 times 10 to the negative 14th, specifically at the temperature of 25 C. So this can change at variable temperatures, but for our purposes, just assume that we're at room temperature. So let's take a look at sample exercise 4, and we're asked to calculate specifically here the concentration of our aqueous hydroxide ions. So how can we figure that out? If we're given the hydrogen ion concentration, which we know is really hydronium, we can use this Kw expression and the equivalent value here, 1 times 10 to the negative 14th, to solve for hydroxide. So we know that our value here, 2 times 10 to the negative 6, this is our H plus. So if we were to write this out here, we would plug in our value. So 1 times 10 to the negative 14th would equal, this is what we're solving for, times, and we know that value, right? 2 times 10 to the 6th. So let's divide both sides by that. So we get this rearranged equation here. So if you plug into your calculator, 1 times 10 to the negative 14th divided by 2 times 10 to the negative 6th, we're going to get that our hydroxide ion concentration for this question is equal to 5 times 10 to the negative 9th molar. All right, so we're going to do a similar thing here using the Kw expression to solve for B. So in this case, this equals this. So we could think about if we were to plug in, Kw is this plus this, right? That's the same as saying this squared, right? And we know that that's equal to 1 times 10 to the negative 14th. So what we can do to solve for H plus, which we know will be equal to our hydroxide, we could take the square root of both sides. And in this case here, we'll see that that's equal to 1.0 to the negative 7th molar. Again, this is both the hydroxide and the hydrogen ion or hydronium ion concentration.